Okay, welcome to Math 12A. Today is just a review. Sorry, I'm just grabbing markers. Today is just a review, that's it, because your test is on Thursday. So there's no homework for today other than you need to be studying. So what I thought I would do is what I normally do in class, and that's just a quick review to remind you what is in this section. So in section 7.1, that was geometric proofs. In section 7.1, that was geometric proofs. You really need to know your information about opposite angle theorem, transversals, all of that. If you didn't write it down, if you did not go through the videos and write stuff down as you went, then you need to spend some significant time studying today. In the geometric proofs, it will be like the homework where there will be statements and reasons. I will provide some of it. You have to fill in the blank, basically. I don't try and make it overly hard. There will be one or two of those at the most on the test. That's not where we focused our time. That's not where the focus of the test will be. So again, just one or two of those. Then we went to section 7.2 where we talked about chord properties. And so we talked about some different things. We talked about the fact that if you have a circle and there's the center and here's a chord, if you have a line that goes through the center of the circle and touches the chord, it automatically cuts that chord in half so that this side and this side are the same, and these are automatically perpendicular. Wicket, lay down. Wait. Oh, we're gonna go crazy, just a second. So I'm just waiting for them to stop barking. Okay, I think, no, I thought they might be done. They're not done. All right, so, oh my goodness. You hear my crazy one that doesn't really bark, right? That's Willow. So in section 7.3, I apologize. In section 7.3, it talks about angles in a circle, and that's where we talked about inscribed angles and central angles. And so we said, I'm going to do this in some colors, I think. Just, it makes life easier. Yeah, that. So an inscribed angle is an angle that is at the edge of the circle. Wherever it comes out, wherever the ends are, that arc, that part of the circle that joins it, we say that it is subtended by that arc. All right? Now, if you had another inscribed angle, and it also came out to these 2 points, 2 inscribed angles that are subtended, that are joined by the same arc, are the same. So if this was 30 degrees, this would also be 30 degrees. So if I'm asking you to find something, that could be a key to finding something. Now, there are also central angles. So let's say this is the center of the circle, and the central angle comes out to here. It comes out to the same place as these 2 angles, but it's a central angle because its angle's at the center of the circle. The central angle is 2 times bigger than the inscribed angle. So this would have to be 60. All right, the central angle is 2 times bigger. Don't confuse that. I mean, even look at it. This looks bigger than this one. So even by looking at it, you should be able to tell. And And that was really it out of that section. It felt like we were learning a lot, but we really weren't in each section. That's what came out of that section. It's not that the explanation is that hard. It's going to the circle, and when it's got all these lines in it and everything, figuring it out for yourself, that's the hard part. All right. Section 7.4, we dealt with cyclic quadrilaterals. And what we mean by cyclic quadrilaterals. Belle, stop. What we mean by cyclic quadrilaterals is the word cyclic is related to circle or cycle. And so it means in a circle, and quadrilateral has that quad in there, meaning four-sided. So a cyclic quadrilateral is a four-sided object where all the corners are on the edge of the circle. They're touching the circle. That is a cyclic quadrilateral. Now, there were some things that was said about a cyclic quadrilateral in section 7.4. First, the opposite angles are supplementary. So angles opposite one another are supplementary. And if you don't know what supplementary is, you should at this point. But supplementary means they add together to make 180 degrees. If it's a cyclic quadrilateral, the opposite angles will add up to be 180 degrees. So these two would add to give me 180 degrees, or these two would add to give me 180 degrees. Really, to be honest, and an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So let's say this extended out here, and I wanted to know what that angle was. That's an exterior angle. It's one that's outside the cyclic quadrilateral. It is equal to the interior opposite angle, okay? The interior opposite angle. So in this case, the question mark, that one out there, is whatever x is. Those would be the same. Whoops. Sorry. And that's pretty much it. That's what we got out of that section. The thing is, you then had to put it together with things like inscribed angles subtended by the same arc are equal, because they started mixing things together at this point. So it got confusing. Section 7.5 dealt with tangents to a circle. I really apologize for my dogs. My husband went outside and they're just freaking out. I don't know why. So tangents to a circle. If we have a circle, a tangent line, just 1 second. Who's over there? What am I hearing? I don't know, I thought a dog was into something, sorry. So a tangent line is one that only it goes by the circle and touches it, but it only touches it in one spot. So a tangent line might do this, meaning it only touches it in this one spot. Now obviously it's not drawn perfectly, but that would be a tangent line. So one of the theorems that they said about a tangent line is that if you have a radius and that radius goes out and touches the circle at the same point where the tangent point is, then the tangent and the radius are automatically at right angles to one another. Okay? So if you have a radius, touches the circle at the same point that the tangent line touches the circle, then the tangent line and the radius are at right angles to one another. And then it said if you have another tangent line, so let's say you had one on this side, okay, and it came out, okay, like this. At some point, these two tangent lines are actually going to meet up, okay? Wherever they meet up like that, outside of the circle, the distance from the tangent point, so from here to the point where that tangent line meets, these two are the same. So from the tangent point to where they meet, these two lines have to be the same length from the tangent point to the point where they meet, okay? And then the last one that we talked about is the one that I find hardest to explain, and that is this. If you've got, let's say, two tangent points there, and let's say inside the circle you have some chords. You have a chord going here, you have a chord going here, and you have a chord going here. So basically it makes a triangle inside, all right? The angle between this tangent line and this chord, we'll call it X, is the same as, okay, so it's touching this chord, right? The angle opposite that chord is this angle. So this one and this one have to be the same. The angle between a tangent line and a chord is the same as the angle that is opposite that chord. So again, I could do that down here. I could say, here's a tangent line, here's the chord, it's touching this, so we'll call this Y, it's touching this chord. The angle opposite that chord is up here, so that is also Y. I find that one hard to explain. I think, after teaching it 5 years, it's probably been longer than 5 years, however long I've been teaching this, you'd think I'd be able to explain it, but I just find it hard to put into words. Section 7.6. Section 7.6 was not about this. It was actually about if you have a circle and you have a sector or a piece of it, okay? The angle, they label M. I mistakenly called it theta because another textbook calls it theta. This is R, and this is my arc length right here. From here to here, this is my arc length. And so there was two formulas. If I want to know the arc length, which would be here, that is M over 360, so this angle over 360 times 2 pi r, because 2 pi r is the circumference of a circle. We also might be asking about what is the area of this sector. Area is M over 360 times pi r squared, because pi r squared is the area of a circle. So that's section 7.6. It's just those two formulas. And then the last section we did was section 7.7. Section 7.7 is really just about angles and polygons. So if you have a really weird, wonky, wonderful shape, something like that, that is a 1, 2, 3, 4, 5, 6-sided shape. So you can actually figure out what should all the angles in that polygon add up to. It would be 180 times n minus 2. Just 1 second, I'm going to yell at a dog. Belle! No! That's sass. No! N stands for the number of sides. So if this, oh my word. So if this is a 6-sided object, we have 180 times 6 take away 2, so we have 180 times 4. Whatever that is, all the angles have to add up to be that. So you did a few questions like that. I did a few in terms of finding all the angles and everything. I did a few of those in a video. If you didn't watch that video, it might be worth your while. It was in the answers to section 7.7 section. It might be worth your while to watch. By the way, if you're not watching all these videos, you should be. Based on the number of views, I don't think y'all are. Unless when you play it through Google Classroom, it doesn't count as a view on YouTube. I don't know. But when there's 4 views and there's like 7 or 8 of you in the class, that tells me something, right? So that's it. We're going to do the test on Thursday. So class time is 9:50 to, well, really till 11 o'clock. So at 9:50, I will upload the test and you will have an adequate amount of time to do it. It shouldn't take you any longer than the hour. Here's what I find about this test. Every year, if you find this section easy, you can do this test really, really fast. Like really fast, like under a half hour. There is usually at least 1 or 2 that you get stuck on. You can't figure it out. And then you sit for like half an hour just staring at this one question. Don't do that. So you will be cut off by 11 o'clock. You will be cut off. Because if you haven't finished it by 11 o'clock, it means you're sitting and staring at something, trying to figure it out. You're stuck somewhere. And staring at it for another half hour isn't going to help. So please practice some of those would be my suggestion. And yeah, I would love to answer questions. The problem is I can do 1 million of them on the board. They're all going to be different. You really need to know those rules that I just went over, okay? So at 9:50 on Thursday, we will see, well, I won't see you. I will communicate with you then. All right, good luck on the test.